Welcome to Chemistry with Mr. Schmidt. We have electron configuration and Bohr models. That's what we're going to be going over today. And if we look at our learning scale, we're going to cover some things in particular. And they are going to be that the student can draw a Bohr model to show the number of each type of subatomic particle. You should be able to write the number of each type of subatomic particle already, especially if you have mastered the previous objective. And then you're going to show the placement of those particles within the atom. And so what you should know already is that protons and neutrons are found in the nucleus of the atom. That's a fairly easy part. The next part is the electrons surround the nucleus are located by energy level. Well, one thing about drawing the Bohr model and locating electrons by energy level is it would be much easier to do so if we know how to write how the electrons are configured within the atom. And so we're going to kind of blend this idea with the next objective, which is the student can use the quantum model to write the electron configuration. We are not going to get to drawing orbital diagrams in this video, but we are going to be able to write the electron configuration so that we know how these electrons surround the nucleus and how they are located by energy level. So that's the major idea here. If we go to our major presentation here, we have a periodic table and also what I call a yellow brick road. So when we refer to the yellow brick road in class, we're referring to this document right here. And I will show you how to use that in this video. A couple things I wanted to point out, and these are from your notes. We talked about how electrons were configured by energy level, and by now you should have labeled your periodic table to reflect that we have certain regions, and this region here, and with helium, we know is the S region. And if we go to this section here, outlined in red, this is our P. And then if we go to another section, hopefully I can get another color here. Just make sure that, let's go to this orange section, is going to be D, and then this last bottom section is F. All right, so we have our S, P, D, and F. All right, so we should know those sections, and you can see in our yellow brick road, those are also reflected, S, P, D, and F. You can see those there. So you know we're going to be using them. All right, but in energy level 1, we only have the s orbital. And from a previous slide, we said that the s orbital only holds 2 electrons. And you can see that on our periodic table. If you go across the S, and let's go back, let's take a little side step back here, and let's talk about those energy levels real quick. So if we look at our period number, meaning the number of horizontal rows, we could look at this as 1, 2, 3, 4, 5, 6, 7, and we can think of those as energy levels, but only for the S and the P. And if you look at your yellow brick road, you will only see 7 for S and P. You will not see that for the D and the F. So these hold true for being energy levels for S and P orbitals only, but not the D orbital. All right, so, and we'll talk a little more about that in a little bit. But if we think about those being energy levels and we wanted to just simply count in the S, you can see an energy level 1 we have S1 and S2. In energy level 2, we have S1 and S2. So there's one S1 in energy level 1, one S2 in energy level 2, and then we have lithium as 2S1 and beryllium as 2S2. And if we want to go to sodium and magnesium, that would be energy level 3, 3S1, 3S2. If you go down, energy level 4, 4S1, 4S2. So this is how you read these. Energy level 5, 5S1, 5S2. And you go, we'll do one more. Energy level 6, 6S1, 6S2. And you could go down to 7. But my point is, you never see more than S2. You see S1 and S2 because the S orbital can only hold 2 electrons. Now, in particular, we're talking about the first energy level, and it only has S orbital, and we can see that in the first energy level, which we see right here, energy level 1, it only has hydrogen and helium, and they're both in the S orbital. They're both in the S orbital. So in energy level 1, you do not see D or P electrons in there. Those shapes are not represented in energy level 1. So you will not see D or P or F in energy level 1. Energy level 1 has only S. Hydrogen and helium are only in the S. So you can have 2 electrons in energy level 1. And so that's why it says it only has 2 electrons. Only has 2 electrons. And it says 1s2. So if we were going to write the electron configuration for those electrons, for atoms in energy level 1, we only have 2 elements, all right, 2 atoms. We have hydrogen or we have helium. And they both have a different electron arrangement. In hydrogen, we have only 1 electron, and it's in the S orbital, and it has 1 electron. So 1 energy level, S orbital, 1 electron. So what does this mean? This symbol means that 1 represents the energy level. So we're in energy level 1. So we say the big number right there is energy level 1. The S represents the orbital. And then this 1 here represents the number of electrons. So we see here that we have hydrogen is in energy level 1, S suborbital, 1 electron. Now if we look at hydrogen, we know that hydrogen has an atomic number of 1, right? Hydrogen has an atomic number 1. And so what we can say there is if it has an atomic number 1, it means it has 1 proton, and that means it would have 1 electron. So it would have a charge of 0. This would be its charge of 0. We have 1 positive charge particle plus 1 negative charge particle, and it gives us a charge of 0. And we should be aware of that idea by now. And so we can actually account using our electron configuration to see if we're right by counting these little electrons here at the top. We can count this and see if we've got our configuration correct. And we should have 1 electron for a neutral atom of hydrogen. And we do. So how do we get a Bohr model out of that? In drawing a Bohr model, you simply draw a nucleus. And we're going to call this hydrogen 1. And that means it's isotope of hydrogen, which we have a mass number 1, and we have 1 proton. So in our nucleus, we're going to have 1 proton. We're not going to have any neutrons because our mass number is 1. So we can't have any neutrons, otherwise our mass number would be 2. And so here's our energy level surrounding our nucleus, and we'll label it energy level 1. And how many electrons should appear? I'm going to make my electrons red for effect, and that's 1. And so this would be a good Bohr model for hydrogen. And that model is from Niels Bohr. He was the scientist that came up with this model. So we could also do that for helium. Helium is in energy level 1. It's in suborbital S, but if we go to our periodic table, we're going to see that it's not S1. This is S1. Hydrogen is S1. Helium is 1S2. So helium is 1S2. Now, if you think of helium, and let's say that it's an isotope, let's call it helium-4. Let's say it's an isotope of helium, helium-4, and it has an atomic number of 2. If it has an atomic number of 2, then it should have 2 electrons, and it does. So we have a helium with a neutral charge because it has the same number of protons and neutrons. The same number of protons and electrons. And so we can draw our Bohr model, and in this case, we are going to have neutrons. Here's our nucleus, and we're going to have 2 protons. In order to get to 4, how many neutrons would we need? That's right, you would need 2 neutrons. 2 plus 2 is 4, and then you have 1 energy level. And how many electrons are in that energy level? 2. And so that would be a good Bohr model for helium. And so we use our electron configuration to determine where these electrons are by energy level. And it's fairly easy when we're only dealing with energy level 1, because we know all of our electrons are going to be in energy level 1. And then the maximum number of electrons that we're going to have in energy level 1 is going to be 2. All right, because there's only 2 atoms represented in energy level 1. All right. So I'm only going to go through one more part in this video, and then we'll make another video as we go into energy level 3, just to keep the time a little bit lower on the video. Okay, so on second energy level, we have S and P. We have S and P, and we can see that if we go to our periodic table. Here we are at energy level. Here we are at energy level 2. All right, and in energy level 2, let me erase some of the stuff that I've had on here already. Energy level 2, we have S, and we also have P. That's all in energy level 2. So we can see that we have 2. Now, if you count the total number of electrons, it's going to be 6. 1, 2. Let's make sure you can see this. 1, 2, 3, 4, 5, 6, 7, 8. And I meant there's going to be 8. There's 6 in the P and 2 in the S. So there's going to be a total of 8 electrons, not 6. I misspoke. So we have a total of 8 electrons. But we still have to write our electron configuration for that. All right, we have to know how those electrons are arranged by energy level. So let's just choose an atom from energy level 2, like beryllium. Let's choose beryllium, and let's write our electron configuration. Now, if we write our electron configuration, what we are going to first do is find out where is it ending. It's ending at energy level 2. S1, S2. So beryllium is in 2, S2. Well, if we look at beryllium, it has 4, has an atomic number of 4. All right, and we're gonna have this have an isotope be beryllium-9. Has an atomic number of 4. Well, how many electrons am I accounting for here? Yeah, that's right, only 2. So we can't say that's the complete configuration because it it's only accounting for 2, and there's 4. So we have to account for those electrons in energy level 1. And so what we have to do is we have to go back and write the configuration for this hydrogen and helium. And so what you would get is 1s2 and then 2s2. Now if I count all my electrons, I have 4 electrons and I have 4 protons. One other way of doing this is to use your yellow brick road. And so we can still write 2s2 because we can find that on our periodic table. And then we go back to our yellow brick road. And on our yellow brick road, this is very important that you follow the symbol that says start here. And under start here, you're going to write, you know you're going to end at 2s2. This is where you're ending. So you're going to start here and you're going to go to where you end. And you follow the arrows. So we'll write 1s2. We go back down to our configuration and we'll write 1s2. And then we keep going. We follow this, and this is fairly easy. Oh, we're there, 2s2. So what we should have for beryllium is 1s2, 2s2. And sure enough, we do. We can check this by counting the number of electrons. 2 plus 2 is 4 electrons, and we have 4 protons. So that means we did our configuration properly. So that is a fairly easy one. Let's look at something a little more complicated, like oxygen. And we have oxygen, and let's call this oxygen 16. We're gonna give it the isotope oxygen 16. And oxygen, it doesn't not matter what oxygen it is, has 8 protons. All right. So the question is, what is the electron configuration, and then how would you draw the Bohr model? So the electron configuration is now, this is a little bit different because now we're dealing with a p orbital. So in the p orbital, you have to count these individually. And so you would do this by saying you have energy level 2, 2p1, 2p2, 2p3, 2p4. All right, so we're at 2p4. All right, so we're going to end our configuration with 2p4, but clearly we do not have the correct number of electrons. We should have the same number of electrons as we do protons, and we're a little bit short. So we have to account for all of the electrons in the first energy level and all the others in the second energy level that would be in the s orbital. So you can do that by following your yellow brick road. So in this time we ended at 2p4. So we're going to go to our yellow brick road, and we do not find 2p4 on the yellow brick road. We find 2p6. But this is where we're going to end. Only we're not going to write 2p6, we're going to write 2p4, which is already written. And you simply start here, 1s2. So you write it, go back and write 1s2. Of course, this is easier for you. You don't have to change screens. 1s2. And then when you're done with that, you keep going. The next thing is 2s2. And then we go to the end. When we stopped at 2p6, except for we didn't go to 2p6, we went to 2p4, and we had already written that down. So if we count our electrons now, we have 2 plus 2, which is 4, plus another 4, which is 8. And so you have all of your electrons counted for. If you want to draw your Bohr model, simply draw your nucleus. The nucleus should have 8 protons, because that's our atomic number. And this should have 8 neutrons. And 8 plus 8 gives us 16, which is our mass number. How many energy levels do we have represented? That's right, we have 2. So here we have energy level 1, energy level 2. Now where are my electrons located by energy level? In energy level 1, I have 2 electrons. So I'll draw my 2 electrons in energy level 1. But if you notice, energy level 2, there's 2 of those represented there. One has the s electrons and one has the p electrons. In the Bohr model, we are not showing the difference between S and P. We're just showing that the raw number of electrons. So in this case, you're going to add these up, and it will be 2 plus 4, which gives us 6 electrons. So we should have 6 electrons in our second energy level. 1, 2, 3, 4, 5, 6. You do a quick count, and you should have 8 electrons in your picture total. 6 in the second energy level, and 2 in the first energy level. So that's how you would do that. All right, well, I thank you for watching. I hope this really helped.